In this particular lecture, we're going to have a look at how we can animate images, assuming here that we have a sequence of frames and we have to play back that sequence to provide an animation. Animations are quite commonly used, particularly within 2D games where we do have separate frames of animation. There is a distinction here, for example, with 3D, and this is a three-dimensional picture that we have, or from a three-dimensional game, Minecraft. Within this, though, animation occurs differently, where you have a skeletal mesh and you'd be transforming that particular mesh within the game. Equally, if we're talking animation, we can also, when we looked at how we can use matrices to transform an image by giving it a position and a different shape, that's another form of animation. So the third one, and the one that we're particularly interested in within this talk, is looking at a sequence of frames which we will iterate through, and by doing that, provide the appearance of an animated entity. As mentioned, we're simply dealing with a sequence of images, and each of the frames within that sequence slightly differs. And it's been carefully constructed so that if we play back that sequence sufficiently fast, it will appear to us to be a continuous, unbroken animation. You might want to think, okay, how fast is that? How fast do we need to play it back so that it will appear as continuous animation, so that it will look animated to us? And you get a range of options here from, so we need to play back at 50 frames a second all the way down to 5 frames a second. How fast is fast enough? And the answer to this may surprise you, may not. If you think about TV, okay, there's different formats across the world, but TV typically 24, 25, 30 frames a second. If we're talking about movies and high-end movies, things like for example, The Hobbit would be one recently recorded. That's recorded at 48 frames per second. So in terms of games, quite often we're running games at a faster pace than a lot of recorded content. Sometimes it's necessary, depends upon the speed with which the player can change the camera within the game. A lot of movies, that's actually up to the director in terms of the shots that are taken. So let's have a look at a couple of examples, and there we have 6 images being shown, and these are 6 frames of effectively a bounce animation. I want to show you a couple of different speeds at which we can play that back. Firstly, at 2 frames a second, it's not smooth. If we're looking at that, it very much appears to be discrete images. One image is displayed after the other, and that's how we perceive it. If we were to increase the speed up to 10 frames a second, then it's just reasonably smooth. We can look at that and we can see a bumping or a bouncing ball. So it's not too bad at all. And some time ago, when animated movies tended to be hand-drawn, it was fairly standard then to hand-draw them about 12 frames a second. And we have the horse running roughly around that interval. And it looks reasonably smooth. Our brains do an awful lot of the interpretation that because it's plausible from one frame to the next and it's sufficiently close that we're not noticing any difference, we very happily interpret it as continuous motion. If we're looking at games and how we will get our different images, there's a few sources that we can get it from. So we are talking about bitmaps, but how we package up the frames within the bitmaps, that can differ. You could have potentially a whole series of different files, each file containing 1 frame of animation within the bitmap. You can also have image strips. Could be horizontally typically, where within that we have a number of different frames, and each frame is set next to one another. The example you see in the bottom of the screen here is an image strip where all of the frames have the same width. Sometimes, by way of saving space, they use variable width, that if you look at the animation at the very start of it, there's a reasonable amount of white space around that, so that potentially could be stripped out. It makes it more difficult then, because you can't assume that every frame is, for example, 100 pixels wide. Rather, you've got to have a list saying that the first frame is 24 pixels, the second frame is 38 pixels, and so on. Finally, we might have an image sheet. It's similar to strip, except we're tiling the images horizontally and vertically over it. Little aside, for best performance, if we are drawing animations, ideally we want to have these things stored in a single image sheet, have them all in the same sheet, and if we are drawing a bunch of things that objects use the same animation, then we should draw them as a batch together, and that'll maximize the draw performance. So let's have a look at playback, how we can actually sequence a series of images to give the appearance then of continuous animation. We will be integrating this within our update and our draw loop, and each of these components will have their own particular tasks. In the update phase, this is arguably where we do all the hard work, but it's not that hard. We are working out what is the right frame that we should be displaying at this point in time. And that includes the decision when it is appropriate to change from one frame to the next frame within the animation. The draw phase is arguably simple. All we do then is we've worked out what particular frame we're drawing from, and we simply draw it when requested to do so. Have a look at some fragments of code here that will hopefully illustrate this. We're assuming that we have, in this case, an array of images available to us that we're iterating through. Equally, if it was an image strip, then we would be calculating which particular, for example, rectangle within that image strip that we would be drawing from. So it makes it slightly more complex, but not too much overall. But for this simple example, we're going to assume an array of images. If it were an image sheet, then this could be an array of rectangles into that particular image sheet. The other variables that we have a play count, and this will be the number of times that we will play this particular animation. So for example, a value of -1 could mean continually loop. A value of 0 could mean pause it. A value of 1, 2, 3, play at that number of iterations. We'll have a home frame, and this is the particular image or frame that we will be displaying whenever we're not animating. So this could be because we've yet to start the animation, so maybe it's going to be the first frame. It could be that we want to animate something once and then stop when we get to the end. It could be the last frame of the animation. We will have a current frame variable, and this will let us know at this point in time what is the frame that we should be displaying. So if we are mid-animation, then this will determine the particular frame of the animation that we're going to pick. We have an animation period, which will be the number here, we're assuming milliseconds, that a full iteration over or playback should take. There's different ways of doing this. Sometimes you might express it as the period of the full animation. Sometimes you might say for each frame of the animation, how long should it be visible on screen? So it swings and roundabouts. Start time, finally, is where, or rather when, we started feedback, sort of playback of the animation, and we will use this as our point of reference to work out what is the appropriate frame, current frame, to use at this point in time. Here's our update method and our draw method at a high level. So update method, we're going to determine the current frame as simply working out what is the right frame to use, and I'll show you that in the next slide. We've got a sort of a slide's worth of code. And for our draw method, all we do is we simply draw it out. We know the frame, that's what we've worked out in the update, and we draw it out at whatever position we're meant to draw this thing out to. So here's the determine current frame that we're calling within our update method. It may look a reasonable amount of code, but this is it in its totality. This is all that we need to provide a reasonably flexible playback mechanism. So we'll have a sort of a step through the 20-odd lines of code that we have here. At line 3, we are working out, well, what is our current time? We're calling, or whatever method we want for getting the current time. So quite often within our sort of Java Android one, it's system.nanotime. I'm assuming here we've got a long value, so it's going to give us the number of milliseconds or nanoseconds or whatever, but it's going to be a numerical measurement of time that is accurate at the level of a millisecond. Line 4 and line 5, this is where we are checking to see are we starting playback, are we commencing playback off this? And the little aside, start time will be reset to -1 anytime the play count is changed. So whenever the developer sets up a play count, then we will reset our start time back to -1. And this will be our indication that we've reset the animation. That being the case, the first time we're determining the current frame, we should work out, well, what is the current time? This is our point of reference that we will measure the playback from when we start it. Line 7 to 10, this is basically the fragment that works out when we have concluded playing our animation. So a play count is greater than 0. So if it is 0, we're not playing it, we're not going to do that. If play count is -1, which was our notion to continually loop, then we're not going to trigger this as well. So if we are greater than 0, we're playing it back once or twice or 3 times or whatever. Then line 8 and 9, we are saying if the current time minus the start time, this is how much has elapsed since we started playing this. If that is greater than play count multiplied by the animation period. So animation period tells us how long we're playing the thing for. Play count, how many times are we going to play it. Those two things multiplied together gives us the total duration of the requested playback. And as soon as we exceed that, then we set our play count to equal to 0. We say we've done our job, we're going to stop. Line 12 and 13. So if we have a play count of 0, so this is either because we're not yet playing or we've concluded it, then the current frame is whatever home frame we have identified. We'll use our default frame. We'll pick it at that point. And that's really the end of that if. The else bit is the component that says, okay, we're currently playing back our animation, we're currently mid-animation, what is the appropriate frame that we should be returning? Because this really is sort of two broad statements. In lines 15 and 16, we're working out how long into the animation we are. And this is for this particular animation period. So if we're animating 3 times, and we've done 2 of the iterations, then this time into animation period will give us how far we're into the third one. How do we do that? We work out current time minus start time. This is just how much time has elapsed. And we do the modulus here for the animation period, and that gives us the portion into the current period that we're at. Line 17, 18 and 19 is the simple line that works out what is the right frame of animation. So it's quite straightforward. We're working out how far we're into the animation period. This will be, say, number of milliseconds. We're multiplying that by the number of images that we have available, and then dividing that by the overall animation period. So if we have 10 images available, we have an animation period of, say, 1,000 milliseconds, and we are currently 100 milliseconds into it, then we'll get an image of 1. But for 500 milliseconds into it, we'll get an image of, say, 10 images, an image of 5 coming out of this. So it does a simple mapping onto it. We're then at the very bottom returning the current frame. So no matter if it's play count 0 or not, when we work out the right frame, that's what we return. That's what we'll then use to draw it. So key takeaways on this, a couple of simple ones. Animation, for this type of animation, it's nothing more than controlling the playback of a sequence of images. It's actually mostly our brains that do the hard work of interpreting it as continuous motion. And playback's reasonably straightforward. Arguably, you'll probably put more time and effort into actually manipulating and preparing the source material, the raw data, in terms of how you load it in, how you segment it, how you extract out the different frames of animation. Once you've done that, playback itself is actually reasonably straightforward.